For letter C, if G is the centroid of triangle ACE, AG is 8. Okay, now, if AG is 8, that's the 2/3 section of AD. So if we cut 8 in half, that gives me 4. So from here to here, D to G, this is 4. Okay, so here it asks us what is the length of GD, that would be 4. And then what is the length of AD? Well, 8 plus 4 is 12. Then GF, see here, so GF, this is the shorter section of CF, okay? If that is 7, I need to go ahead and figure out the larger piece here. So that is 7 and 7, okay, which should be 14. I'll go ahead and fill that in. CG is 14. Then we are given that BG is 5, which again, this is the shorter section. So this is double that, which is 10. So it says, what is GE? 10. And then what is BE? Well, 10 and 5 make 15. All right, for letter D, if Z is the centroid of triangle TUZ, TZ is 60. This means that to get ZY, which is half of 60, I would put that's 30. So I know that ZY is 30. Then it says XZ is 28. So this piece is the longer piece, so it's 2 times 28, which is 56. And that's ZV, so ZV is 56. All right, then we have WZ is 25. Okay, so this is the shorter piece. So the longer piece of that length is double 25, which is 50. All right, so ZU is 50. TY is 60 plus 30, so that's 90. And XV is 28 plus 56, which is 84. All right, for this problem, kind of hard to read, it says in the diagram below, XA is 8. What is the length of XB? All right, so XA is 8. If I look at the entire segment, we see that A to B is the shorter distance. So if I take half of 8, we get 4. Okay, so this AB part is 4, and this XA was given to us as 8. It's just got kind of cut off here where the staple is. Okay, so what is the length of XB? 8 plus 4 is 12. For letter E, M is the centroid of the triangle QRS. QM is 4x minus 2. And QV, the whole distance, is 87. Find the value of x. All right, so we know that QV is 87. That's the whole distance, okay? And we also know that this other little piece, well, the 2/3 piece is 4x minus 2. So we can think of it as this part is 2/3 of QV. So we're going to put 2/3 of the entire distance. Now, we got to clear this fraction. So we could do a few things. We could take 2 times 87 and then divide that by 3. And then that would give us 58. We could multiply everything by 3 to clear it out. This seems to be a little bit easier. So I just went 2 times 87 and then divided by 3, got 58. Then I add 2, I get 4x equals 60. If I divide by 4, we get x is 15. All right, now for the new set of vocabulary words, we have altitude and orthocenter. So we need to know that the altitude goes from the vertex and it is perpendicular to the opposite side. So this is your altitude. The biggest hint or the giveaway is that when you see that right angle, we know that this is going to be an altitude. So a segment joining a vertex to the opposite side so that it is perpendicular to that side. So in this example, this is pretty much like this one here. You would just draw it straight down to be perpendicular. On this one, we can't really do that. We can't really draw one. So what happens is that you can actually extend this triangle out, and if you drop the segment down, it creates perpendicular. So this part would be here showing the altitude. And then in the right triangle, this piece right here is already drawn for you. It's already the altitude. It goes from the vertex, drops straight down, creating that perpendicular angle. So then the question is, what happens, or what's it called when you draw all three of those segments? When you draw all three altitudes, it creates this right here, this piece, or this point, and this point is known as the orthocenter. So the three altitudes of a triangle intersect at the point called the orthocenter. Use the diagram to the left to answer the following questions. So I want you to list the altitudes first. So going from A, we'll work our way around, A to E, B to F, and then C to D. You need to name the orthocenter, which is point P. It says the lines that contain the altitudes of a triangle are concurrent. So here is some other examples you can see of orthocenters. Okay. And the altitude is drawn. So in this problem it says for triangle PQS, if PR is a median, an altitude or neither. So if I look at PR, I see that it comes from the vertex and it creates this perpendicular angle. Well, if it's creating a perpendicular angle, this is an altitude. And the reason it is perpendicular to QS. Okay, so here's QS, it's perpendicular to QS. They want to know, is QT a median, altitude, or neither? Explain. So QT, it's a median because it comes from the vertex, it goes to the center, and I know it's the center because I see these little marks showing congruency. So I would say this is a median. And the reason is T is a midpoint. T is a midpoint of PS since PT is congruent to TS.